Good morning to all of you. Today we are going to discuss about PN junction diode. And these are the topics we have discussed in the previous classes. Formation of a PN junction, formation of positive ion, then negative ion, depletion region with the depletion region. So today we are going to discuss the PN junction semiconductor diode, forward biasing, reverse saturation current, and reverse breakdown voltage. Introduction about PN junction semiconductor diode. As we know that PN junction diode is a two-terminal semiconductor device which allows the electric current in only one direction while blocks the electric current in opposite or reverse direction. That is, the diode is forward bias, it allows the electric current flow. If the diode is reverse bias, it won't allow the electric current flow. And this is a symbol of the PN junction semiconductor diode. The first one is forward bias condition. The anode terminal is connected to the positive terminal of the battery and the cathode is connected to the negative terminal of the battery. During the reverse bias, just opposite. Anode is connected to the negative terminal of the battery and cathode is connected to the positive terminal of the battery. Next, biasing of PN junction diode. The process of applying the external voltage to a PN junction semiconductor diode is called biasing. External voltage to the PN junction diode is applied in any of the two methods. One is forward biasing, another one is reverse biasing. If the junction is the diode is forward bias, it allows the electric current flow. Under forward bias condition, the P-type semiconductor is connected to the positive terminal of the battery, whereas N-type semiconductor is connected to the negative terminal of the battery. In PN junction diode is a reverse bias, it blocks the electric current flow, and the P-type semiconductor is connected to negative terminal of the battery, whereas the N-type semiconductor is connected to the positive terminal of the battery. Yes, the semiconductor diodes are manufactured by two materials, one is silicon, another one is germanium. Both silicon and germanium diodes are having some voltage level, threshold voltage level. For silicon semiconductor diode is approximately 0.7 volts and for a germanium semiconductor is approximately 0.3 volts. For most of the applications, the designing the diode silicon is more preferred over germanium because of this threshold voltage level. That is, silicon semiconductor diodes do not allow the electric current flow if the voltage applied on the silicon diode is less than, sorry, it is not a 0.7 volt, it is in a 0.7 volts. Similarly, for germanium semiconductor diodes do not allow the electric current flow if the voltage applied on the germanium diode is less than 0.3 volts. Yes, next one is the advantages of PN junction diode. We can use this PN junction semiconductor diode in a many different ways. The one is power supply devices, that is, it is going to convert the AC to, that is, alternating current to the direct current. And another one is we can use this PN junction semiconductor diode as a switch. That is, if it is during the forward bias condition, the diode is in on condition. During the reverse bias condition, the diode is in a off condition. So that's why we are using this PN junction diode as an electronic switch. Yes. The next one is forward biasing. You can look at the picture. The first construction of the forward biasing, this is a PN junction diode, semiconductor diode, and which is connected to the external battery. That is, the P-type region is connected to the positive terminal of the battery and the N-type region is connected to the negative terminal of the battery. While applying the electric charges from this battery, these electrons are attracted by this battery positive terminal and the holes are attracted by this negative terminal of the battery. That is, the electrons are moving from N-type regions to P-type region and the holes are moving from P-type regions to N-type region. So thus we can conclude that current flow takes place when the diode is forward bias. So you can look at the picture when the diode is in a zero bias condition and the diode is in a forward bias condition. Look at the depletion region. Under zero bias condition there is no external voltage applied, so the actual depletion region looks like this. When we are applying forward bias condition, the depletion region width will be decreased. That is, there will be a movement of electrons and holes through the depletion region, so it will allow some amount of electrons and holes through the depletion region. That's why the widths are reduced. Under reverse bias condition, look at the picture. The P-type region is connected to the negative terminal of the battery and the N-type region is connected to the positive terminal of the battery. So due to this battery connection, these holes are attracted by the negative terminal of the battery and electrons are attracted by the positive terminal of the battery. So that's why the depletion region width will be increased. So it won't allow any further movement of electrons and holes through this depletion region. So thus we can conclude there is no electric current flow under reverse bias condition. You can look at the picture of depletion region under reverse bias condition. This is during the zero bias condition and this is during the reverse bias condition. So reverse bias condition, the depletion region width will be increased. The next one is reverse saturation current. As now only we discussed, during the forward bias condition there will be a current flow through the PN junction diode, and during the reverse bias condition there is no electric current flow through the PN junction diode. Anyhow, under some thermal energy condition, there will be a little flow of current movement due to minority carriers that are produced in the crystal. That is, when the diode is reverse biased, the electrons from the p-type semiconductor are pushed towards the p-n junction by the negative terminal of the battery. Similarly, holes from the n-type semiconductor are pushed towards the junction by the positive terminal of the battery. This movement of electron and holes constitutes a current called reverse saturation. However, when the reverse bias is increased beyond a certain limit, the reverse current increases drastically. The voltage beyond which the reverse current increases drastically is called reverse breakdown voltage. The diode is said to undergo breakdown when the voltage is increased above breakdown voltage. There are two mechanisms we are going to deal with this breakdown. One is avalanche breakdown, another one is Zener breakdown. That we will discuss in the next class. Thank you.